Hey guys, today we're going to learn about structs in Golang, which is a composite or a group type in the language. So you'll use structs basically just to group or combine an aggregate amount of data of different types. So the cool thing about structs is, again, you can have a various amount of fields or values inside this struct, and it could be a different type. So let's just create a struct right now. So as with any other value or type in Go, you can just set it up with type, and then I'm gonna just do like card because I think I want to create a struct similar to like Yu-Gi-Oh. So inside here, then you have the groupings of the different fields or types. So I know with a Yu-Gi-Oh card, you'll be able to have like the name of the card. So let's do name string. Let's do like attack power equals int, defense power, or maybe instead of power like attack stat equals int. Let's do like type card equals string, and then let's see. I think here we can also do description equals string. So as you can see, we have a lot of different fields or values inside this struct, and they're of different types. So what you do is you include the field, you include the name of that field, and also its types to the right of it. And basically, if you were to initialize this struct, you would add everything there. So if you are missing a certain value, let's say you include data for basically the first four values and don't do it for this last value description, it would just do the nil based or zero based. Sorry, not nil based, but the zero. Yeah, the zero based value of that type. So for string, it's going to be empty string. For integer, it might be zero. For a struct, it might just be an empty struct. So with that, also in structs, you be using them because uh, you have this a combination, a grouping of data, and then also you can manipulate that data within that struct with either value receiver functions or pointer receiver functions. So usually when you're using a struct value and inputting it into a function or moving it around, what you're trying to do is pass it by reference because like, let's say you have like a struct or a whole grouping of data that's very large. It wouldn't make sense to copy that whole value. It would actually make more sense just to point a reference so you're not using as much memory. So if you wanted to attach functions to a struct, then they become methods. So there's two ways you can do that, and I'll further explain that in my functions video that's going to be uploaded very soon. But again, like I mentioned, there's two different types of methods that you can attach to a struct. So you can kind of see like a struct is almost similar to an object in like Python or Java, but again, when you're creating a function, let's say with this card, we want to add um, a modified description uh, um, function, or sorry, method. So if we wanted to do that, we just do func, and then we would name the a func. So modify description. Then I would probably just add a description variable. So I'm just call this description, and then that's a string. And then um, I'm not going to be returning anything. I'm just slightly modifying it. But again, when we were talking about value and pointer receivers, um, you always attach these methods or functions based on this first group of parentheses. So you can either do that in one or two ways. So you can do it like this, where you have like an alias or like a letter or some type of name to the left, and then the actual struct value to the right. So you can see I have the struct data type right here, and then I'm attaching this function to that struct. But if I don't include a pointer, so right here, this is a value receiver type. That just means that I can't modify the underlying data. I'm actually using a copy. So if I wanted to modify the underlying data, which I do, I want to modify the description. And let me just change that to make it more readable. Then I have to include a pointer to that struct. So again, remember, if you do a value receiver, so a value receiver is you're attaching this method with this first parentheses in this manner, then you are just getting a copy of the structure, of the struct. If you want to change the underlying data, then you use a pointer receiver. So once I have that all set up, you can see in the simple function name, I have modified description. I am just inputting the description string right here. So now the other thing with structs is that you can access the data with dot notation. So let's see, like with card, you would do return C dot description. Oh wait, let me just change that. C dot description. So you can see the dot notation. So I have all these values right here. So when I did the dot, you can see like all the other values I have right here: attack stat, defense stat, description, name, type card. So if I wanted to modify that right here, I just do c.description, and the reason you're able to use C instead of card is because, again, you have this alias right here. So you're basically changing that underlying struct right here, but you're using an alias, so you don't have to write it out over and over again. So c.struct equals description, and then you can return a pointer. So yeah, I just return the pointer here. If I'm just modifying it, yeah, let me just return that, and you return pointers with the ampersand symbol and then C. So, and you know, after the second group of parentheses, you have to do the input and then the function name to the left. If you're going to return something, you want to indicate it in the third group of parentheses, or just like the third value. So since I'm only returning one value, I don't have to group it with parentheses. I just have to indicate the type I'm returning and the pointer to that type. So let me just make sure I did that right. Cannot use ampersand type. Oh, okay, so I already have that right there. So I'll just return C. So I'm returning a pointer to that card. So let's say that you wanted to do a value receiver function. You might be asking, like, what's the difference? Like, why would I want to use a pointer one? Again, if you want to change the underlying data, if you just have a function that like returns data, then it may make sense to just use a value receiver. Unless the data is very large. If the data is very large, just have all your functions or methods, sorry, converted to a pointer receiver. But again, like if you just wanted to maybe like add both the attack stat and defense stat, and you're not changing anything, you just do C card, add stats. And then I'm not putting input anything. I'm just honestly returning a combination of the attack stat and defense stat. So I'll use the dot notation to return an integer. So this last part, I'm returning an integer. Let's say you wanted to return multiple values. You can do that by creating the third parentheses group. So let's say you know that you're returning two integers, so like attack and defense. Then you would indicate that there. But since I'm only returning one, the parentheses are not needed, and I just put the type right there. And since I'm just returning the combination of attack stat and defense stat, all I have to do is c.attack stat plus c.defense stat. So this might be a case where you would use a value receiver, since you're not changing the underlying or modifying the state or the underlying struct. Then you're just returning or combining values. But if you were to use one pointer receiver, it's just normal convention to change all your methods to pointer receivers. So um, it's just a convention that Go programmers use. But let's write a main function and just also initialize and create a card variable right here. So with that, I'm going to do the main function and initialize a card. So I'm going to call it, let's do card magician equals card. And then I can just do like name, dark magician. I can do attack stats. And then I'm going to do like 12,000. I'm going to do defense stats. 2,500. I'm going to do type card. And that, since it's a string, I'm going to just do dark. And then description, I'm going to do a powerful magician. Okay, so that would set this variable, and you can see we're using the compact and short variable assignment. So initialize the variable, and then also or declares the variable, and then also initializes it with values. So now I can start using the methods attached to this card value. So I can do, since I'm returning C, I can do a format printf method. So like format, you can return certain values. So with structs, if you wanted just to return the whole struct, you would do a modulus symbol or percent symbol v. So I just want to show like what's involved in this whole new struct. So fmt or fmt.printf, and then I'm going to the card values are, and then this, and I'm going to use the card magician variable. Okay, let's say that you wanted to modify the description, then you can just do that by doing card magician dot modify description. So remember dot notation. Now for this function, I need to include a new description. So I'm going to just put a string saying a powerful or a purple magic user. So and I'm going to reprint that line there, and you should see the difference because we're modifying the underlying data. So if this method was changed to just a value receiver, then the struct would not change, and then you just see the same line printed over twice. But with that little asterisk to the struct type, you have access to modify its underlying values. Okay, and then I can also do the add stat one, so I'll do that later. But I want to show once you change this description, it should show up as well. Okay, so I'm just going to recopy this, and then I am going to do a final printf, and then since I know it's an integer, I'm just going to return or format it to include a digit, or basically be printed to a string. So with that, the combined stats are boom, and then I'm going to do card magician dot add stats. Okay, so I'm going to save this, and after we run this, you can see like all the changes being modified and the underlying values, and then I'm going to just finally show you what an embedded struct is. Okay, so with this, let's see, go run structs.go. Okay, so I'm going to do probably print line. I want to do like a new line statement so it's easier to read. So let's do that. So you're able to do that with the /n. And I'm going to do the same thing here. So I'm going to save and redo it. Okay, so you can see that when the struct is written, you can see that the name is Dark Magician. The attack stats are 1200, 2500. The description at first is a powerful magician, and it changes to a purple magician after we modify it using the pointer receiver function. And we're able to change the underlying data on a struct because we have a pointer receiver. So with that pointer, you have direct access to modify that data. And then finally, that final function, I'm able to print the combined stats of attack and defense. So finally, I just wanted to end this by including one other, not quirk, but useful thing with structs, is that you can embed it into another struct. So let's say I wanted to have a game struct. I could basically put the card struct inside that game struct. So let's just say I had that card values and then something else. Let's just say rating. So rating, and then I'm going to have that be an int. Okay, so basically all the values in struct would be included into the game struct as well, and then game has its own additional value or field with rating. So you can do a lot of useful stuff, almost similar to object-oriented programming, a little bit of inheritance, but it's not exactly like that, but it's similar. Finally, final point is that with any type of these fields, if it starts with a capital letter, then it's exportable, so it can be read outside of the struct and within the same folder as other files. And you can have a mixture of unexported and exported fields. So let's say I made this lowercase a, so this would not be able to be visible to other files within my package, so package main or folder, but name, a defense stat, type, card, and description are available because it is a capital letter. So if I change that back, then everything is able to be exported and usable within that struct. So what I mean by that is, let's say I did have like a lowercase a here, and I was using the card struct somewhere else. So if I try to do like a attack stat, then you wouldn't be able to use that. You get a compile error. So I want to change that back. Everything should be working. And yeah, that's basically structs in a nutshell. Hopefully this is helpful, and our next video is going to go more in depth into functions, so like further explain pointer versus value receivers, what type of inputs you could specify and use in your Go functions, and then also what outputs you can declare and use with your Go functions too. So thank you guys, and hope you enjoy.